Good afternoon. My name is Danyale Berry, a recent graduate from Winston-Salem State University with my bachelor's in exercise science, and I'm a North Carolina Space Grant supported NASA intern for the spring 2021 semester. This project I currently work on is titled Investigating the Performance Characteristics of Material and Neuropathy Treatment Applications. Peripheral neuropathy is the result of damaged and diseased nerve cells that can occur in both the hands and feet. However, for this project, we primarily focus on the feet. Some associated symptoms may include a burning shooting pain, numbness, tingling, oversensitivity or lack thereof, a decreased mobility, and balance when walking. There are many different possible causes for peripheral neuropathy, including diabetes, cancer victims and survivors, athletes, people suffering from severe injuries, even astronauts returning from space. In some special cases, the causation cannot be determined. This is known as idiopathic neuropathy. Neuropathy affects everyone differently, therefore, certain symptoms in one individual may not be present in another. These drastic changes may cause an abnormal gait or walking pattern. An abnormal gait refers to any type of deviation from a normal gait pattern, which can occur when all the necessary neurological input is not successfully sent and received between the brain and spinal cord. On the right, you can see the difference between a normal and abnormal gait cycle. The observation of an individual's gait cycle can help diagnose the cause and evaluate possible treatments for that specific individual. Depending upon how long an astronaut experiences weightlessness can affect their ability to walk when returning to Earth's atmosphere. Below, you can see astronaut Scott Kelly, who spent an entire year on the International Space Station. During space exploration, the human body undergoes many different variables that contribute towards abnormal conditions upon return. Spending a long period of time in microgravity can cause disorientation, loss of bone density, and muscular atrophy. Upon his return, astronaut Scott Kelly did demonstrate difficulty balancing and walking. During the first phase of this project, I had the opportunity to measure the ground reaction forces and gait cycles of various neuropathic victims by utilizing force plate technology and motion capture via the Virtual Environments Lab at NASA Marshall Space Flight Center. I was able to identify at which point in a patient's gait cycle the majority of the force is applied and how the neuropathy affects their gait cycle. Here, the results show what each patient attributed their neuropathy to, the type of gait cycle I observed as each patient walked up and down the platform, and the different types of technology each individual utilizes to combat their condition. Following testing, we are investigating specific materials that contain special auxetic characteristics. Auxetic materials have negative cohesion ratio, thus allowing the material to become thicker perpendicular to the force applied. The application of this type of material has a vast amount of possibilities, from increased comfort and support when walking in various shoe wear to being applied to high performance structures critical to future lunar and deep space exploration missions. The research gathered from this project not only has the possibility to benefit everyday people affected by neuropathy and astronauts returning from space, but also serve as a preventatory measure to help alleviate the painful symptoms that accompany neuropathy. I thank you all for your time, and yeah.